Okay, guys, let's look at it. I want to look at something here on a graph, okay? Let's look at, say, x minus 2 times x plus 4. Let's do plus 2. Let's do that. Okay, guys, this is another form for the parabola, okay? I've got x minus 2 times x plus 2, okay? When you look at this, where are the x-intercepts? 2, 0, and negative 2, 0, okay? Now, without knowing it, where would the axis of symmetry be for this guy? It's going to be the line x equals 0. The axis of symmetry, if I look at any given point here, so if I would look at this, relative to these 2 points, axis of symmetry would be what in relation to those points? In relationship to these 2 points, how could I describe this one? Here's how you go find the axis of symmetry. It's what? In the middle. Another word for in the middle is numerically 1/2. So 1/2 of that. So how do you find the half of 2 numbers? What do you do to find, what do you do? What do you find something that's in the exact middle of 2 numbers? Add them up and divide by 2. That's another word for finding the average or the midpoint or the mean. So that's all you have to do. So if I could tell you the 2 x-intercepts, the axis of symmetry would always have to be where? Not 0. Always in the middle of those. So let's just make it where it's not 0. What if I had, say, x minus 1 and x plus 5, something like that. So if I had this situation, okay, it's clear the axis of symmetry is not at the origin, but where would it have to be? Relative to these points, it would have to be what? In the middle, okay? So this is 1, 2, 3, 4, 5, 6. How far over would I have to go to find the axis of symmetry? 3, okay? That's the axis of symmetry at x equal negative 2, okay? That's what we're going to do with intercept form. With intercept form, you'll be given something that looks like this, and that will give you the x-intercepts. Now, what would change about this problem? What do you think would change if I stuck a negative right in front? It would do that. Did the x-intercepts change? No, they stayed right where they are. Did the axis of symmetry change? No, it stays right where. So it's anchored by those points. All that changed was that it flipped about the x-axis. Okay, so let's just take a look then at an example. This is the way we're going to write intercept form of a parabola. So intercept form is a times x minus p, x minus q. Okay, so you've got, it looks like it's in what form? What form? With an f, it would be, what do you do in algebra? You, not FOIL. To get it to look like this, you had to, what's another word? I'm always cautious when I say a word that begins with that letter. What is another word in math that you get something to look like this? You use a process that starts with an F called factoring. Okay, this looks like it's factored. These are all factors. They are multiplied. Okay, so it looks like it's in a factored form. So y is equal to a, some number, x minus p, x minus q. Okay, my x-intercepts are going to be at p0 and q0. Okay, and then you just described a minute ago how to find the axis of symmetry. It's going to be the average of p and q. What's in the middle of p and q? That's p plus q over 2. So that gives me the axis of symmetry. What's the relationship between the axis of symmetry and the vertex? Describe these. What happens? Yeah, the axis of symmetry goes through the vertex, right? So the axis of symmetry is the what coordinate of the vertex? Okay, the axis of symmetry is the same as which coordinate of the vertex? X, okay? If you look at it, the axis of symmetry is right here at x equal negative 2 in this case. That corresponds to the x coordinate of the vertex, okay? So in this form, if I know the axis of symmetry, that's the x coordinate of the vertex. What if you knew the x coordinate of the vertex? How would you find the y coordinate of the vertex? Plug x in. There you go. If you know the x, you plug it in and you get the y value, okay? So that's all we're going to do here. Okay, so we've got this form of the equation. Just going to walk through that process. So again, as many times as you can, it's helpful to write what's the form of this equation. X minus P, X minus Q. Okay. My intercepts are at P0 and Q0. So first of all, does this parabola open up or down? Okay, you guys have that part because of the negative. Okay. What are the x-intercepts? In this case, it's 3, 0, and what? 7, 0. Those are my x-intercepts because it's in this form, x minus p, x minus q. Here in this case, p is 3, q is 7, or vice versa. Okay. Now, was there a question? Okay, how do I find the axis of symmetry? It's going to be exactly what? Halfway between these 2 points. So what is 3 plus 7 divided by 2? That's 5. So my axis of symmetry is x equal 5. Okay. The axis of symmetry is also the x value of the what? X equal 5. What else lies on this line? What special point? The vertex, okay? If x equal 5 is the x coordinate, how do I find the y coordinate of the vertex? You just plug it in, okay? So what was my original? My original was y equal what? Negative 2. What was it? X minus 3, x minus 7? Is that my original equation? Okay. So let's substitute x equal 5 into that equation. So you're going to get y equal negative 2. And it is what? 5 minus 3? 5 minus 7. So this is negative 2 times negative 2 times, wait, it's negative 2 times positive 2 times negative 2. That number is what? 8. What's the vertex? What's the vertex of this parabola? 5, 8. Okay, so the vertex is 5, 8. Okay. So the vertex is 5, 8, which is right there. Okay. Okay. So I've got, yes. Okay, we'll get that in just a moment. Okay. What are the x-intercepts? 1, 2, 3, 7, 0. Now, one of the visual checks, does that axis of symmetry and that vertex look like it's in smack dab in the middle of those 2 points? Yes, okay, that appears to be right. The y-intercept. The y-intercept is where it crosses what? The y-axis. Y-intercept is also what you get when you set what? X equals 0. You get the y-intercept by setting x equal to 0. You get the x-intercept by setting y equal to 0. So to find the y-intercept, all this means is set x equal to 0. Okay. If you set x equal to 0 in this equation, you get y equal negative 2 times 0 minus 3, 0 minus 7, right? So the y-intercept is going to be what? Negative 2 times negative 3 times negative 7. That's going to be what? 42? So 0, 42 is the y-intercept. Okay, that's a little bit off my graph. Or it's at negative. It's negative. Negative 42. That's a little bit off my graph. So what it tells me is I'm going to cross the y-intercept down here at negative 42. So I'm not able to get that one on my graph. Okay. Sometimes the y-intercept, might show up and it would give you another point you can have on your graph. Okay. So in this case, I know enough now to figure out what this graph is doing. This graph is starting here, and it's going through these 2 x-intercepts. And that's it. Okay. So how does this one feel compared to the vertex? So it's a little bit different. But here's the point. When you look at the vertex form Without doing any work, what can you tell by reading that equation? When you look at it vertex form, without any work, you can tell the what? The vertex form. We call it vertex form because when you look at it, you can magically determine the vertex, okay? Vertex form, you look at it, you see the vertex. Intercept form, you look at it and you see the x-intercepts. How many vertexes are there? One. How many x-intercepts are there? In most cases like this, there are two if it's an intercept form, okay? So in this case, I can look at this equation and I already know 2 points, okay? So you've got 2 points. There's less plugging in that has to happen here. I've got those 2 points. I just need to find the axis of symmetry, which is in the middle, plug in that x number to get the vertex, and then I'm good to go. Okay? Let's do a few examples. Again, what was the domain of this function? Broken record, that's negative infinity to infinity. And what is the range of this graph? Negative infinity to 8. Okay? Okay, let's look at this one. Graph y equal 2x, x plus 2. Okay, my form of the equation is y equal a, x minus p, x minus q. Okay, and I want to look and see how does this equation that I have in front of me fit that model. So this is y equal, what is a? What is a? 2, okay. And then this first one, it's just an x all by itself. Isn't that the same as x minus 0? And then what? X plus 2? So it may help you to think of it like this, okay? So where does this thing open? This thing opens up, okay? What are its x-intercepts? So figure out, if I look at this form, x minus p, x minus q, what are the values of p and q? P is equal to what? 0. Q is equal to? Negative 2, okay? Remember, this formula has a minus sign built into it, okay? So it's x minus 0. This is x minus negative 2, okay? So 0 and negative 2 are p and q. So I know 2 points on the parabola now. I know negative 2, 0, and I know that 0, 0 are on that parabola. How hard is it to find the axis of symmetry on this guy? Oh, this one is child's play for finding the axis of symmetry. It is that line right there. What's the equation of the axis of symmetry? X equal negative 1. If you didn't see that graphically, it's going to be what? P plus Q over 2. So P plus Q is what? Negative 2 plus 0 over 2. That is negative 1. So x equal negative 1 is the axis of symmetry. The x-intercepts are where? Yeah, negative 2, 0 and 0, 0. Okay. How do I find the vertex? You plug in what? Yeah, you have to plug in x equal negative 1 into the equation. So x equal negative 1, that's the axis of symmetry. It's also the x coordinate of the vertex. So if I plug in x equal negative 1, I get y equal 2. And this is what? Negative 1 times x. What, negative 1 plus 2. So I just plug in a negative 1 into the original equation. Remember, the original equation was y equal 2x, x plus 2. Okay. And this is what? This is 2 times negative 1 times 1, which is what? Negative 2. Okay. So that tells me that the vertex is what? Negative 1, negative 2. That is the vertex. And that was what I was asking for here. So the vertex is negative 1, negative 2. So negative 1, negative 2 is right here. Now, does that make sense? This has the parabola open in which way? up, which is what we expected, right? Okay. So what is the y-intercept? You get the y-intercept by setting x equal to 0. So if I set x equal to 0 in this equation, so y is equal to 2x, x plus 2, what happens when I set x equal to 0 there? Yeah, I get 0. So the y-intercept is 0, 0. I sort of already knew that, right? Yeah, so if you set x equal to 0, that's the y-intercept. Set y equal to 0, that's the x-intercept. Here, the x and y-intercept are the same thing. So, do I know enough to graph this guy? Absolutely. Okay. So this graph does this. Yeah, so the range of this function is -2 to infinity. So range is -2 to infinity. And as with all of these, the domain is -infinity to infinity. Okay, this guy right here opens up or down? Down. There's a negative in front of it. So I know it opens down. Okay. What are the x-intercepts? Yeah, -3, 0, and what? 2, 0. Okay. I can look at that equation and see those are my x-intercepts because it needs to look like y equal a, x minus p, x minus q. So that's x minus -3, and that's x minus 2. So -3 and 2, those are my my x-intercepts. I usually find it helpful at this point to graph those. So at -3, +2. Okay. What if you were to figure out, and you somehow did the math and figure out the axis of symmetry is at 5? What do you think is going on there? You have made a mistake, okay? This one, I can look at it and I can pretty much tell where the axis of symmetry has to be between these 2 points. There is no other choice. So 1, 2, 3, 4, 5. What's half of 5? 2.5. So it's going to be 2.5 in this direction, okay? So that's where the axis of symmetry is going to be. Let's just verify it. So it's going to be, the axis of symmetry is p plus q over 2. So it's -3 plus 2 over 2, which is -1/2. So x equal -1/2 is my axis of symmetry. So these are fractions. You will not freak out when you get a fraction, okay? So that is the axis of symmetry. The line x equal -1/2. Now the axis of symmetry is a line. It will always look like this. It's an equation. You will not write down the number -1/2. You're going to write x equal -1/2. It's the equation of a line. Now, how do I find the vertex? What do I do? Yeah, I have to plug -1/2 because -1/2, I know now that is the x value of the vertex. If this parabola opens down, I expect this vertex to be where? Relative to these 2 points, above or below? Where do I expect the vertex to be? Above. What if I were to come and find a number down here for the vertex? I would be wrong because I know this thing opens down. I'm expecting to plug in -1/2 and get some number up here, okay? So let's find the vertex. So the vertex, what is it, x plus 3, x minus 2. So you're going to have y equal negative, what was it, x, is it plus 3, x minus 2? So I've got to plug in a -1/2. So y equal -1/2 plus 3, and then -1/2 minus 2. So what's -1/2 plus 3? That's going to be what, 2.5? And then what's -1/2 minus 2? Is that what, -2.5? Okay. I mean, another way of doing that is what? This is -5/2. So this is what? Negative of 5/2 times -5/2. That's going to be a positive number, which is what? How do I multiply those things together? What's 5 halves and 5 halves multiplied is middle school math coming back to you? Come on, guys. 5 halves times 5 halves. 25 fourths. Okay. Did y'all say that and I just didn't hear it? Okay. 25 fourths. What kind of number is that? That's about 8 1/4. Is that right? Is that correct? 8 1/4. So, no. 4. Oh, no, sorry. It's 7. So 6. Sorry. Yeah. Here you got a negative and a negative. Okay. Negative times a negative is a positive. Okay. So 4 goes into here, what, 5, 6 times. So this is 6 1/4. Okay. So 25 fourths, that is 6 1/4. And so if I go here to 6 1/4, somewhere right in here. Okay. How do I find the y-intercept for x? The y-intercept is what you get when x equals 0. So that means y equal negative 0 plus 3 times 0 minus 2. So this is negative of negative 6, which is 6, right? So it tells me that the y-intercept is at 6, okay, which is about right there. If I go through that point, there's a matching point right there. And now we know what this parabola does. It does this, which is the case. What is the domain? Negative infinity, infinity. What is the range? To 6 1/4. Okay. So the domain's negative infinity, infinity. The range, negative infinity to what was it, 25 fourths? Or okay. So what was hard about this one? But see, you guys pretend like your sophomore is about to take the PSAT, and you will be fine. It's just fractions, okay? So pretty good with that. You could. So in this case, you could have used decimals. This would have been, you would have had negative of 2.5 times negative 2.5. You multiply those together, and you would get, when you get 6.25. So if you do that on your calculator, you would just say, okay, 6.25. You're not exact. You're never exact when you're graphing. You're approximating. So it's okay to go to decimals in this case, if you're more comfortable with that. You will have a calculator on this test. It will not be a graphing calculator. Why do you think it will not be a graphing calculator? Because the graphing calculator can graph. And who do I want to test for graphing? Not the calculator. Come on.